look at the calendar for a second here. Again, the test next week is all on block day. That should be fine in terms of timing. We should have plenty of time. Plus, that buys you really an extra 2 days since you don't have any Wednesday. So, review. We do one sort of new thing today, and then start the review. And then there's 2 full days of review next week. So we should be really ready for this test come next Thursday. Semester review stuff is already posted in Schoology. So there's a review and a practice test. If you plan on taking a final, it's there for you to get rolling on it. Yeah. Are there questions from, let's work a few from yesterday's assignment was average value, worksheet 3, 7 through 14. Fairly straightforward, but 14. I do want to do 14 because 14 leads directly into what we're going to do today. So that's a good question, and we haven't done one quite like that. So anything other than 14? Because I want to end with 14 and then roll into today's lesson. All right, so let's do 13, and then we'll do 14. 13, with calculators, that's nice. In a certain city, the temperature in T hours after 9 a.m. Okay, so that means T represents the hours from 9, like starting at 9. So T equals 0 is 9 a.m. It is given by this function. Find the average temperature. So I know what average temperature is, or I know the formula for the average value. 1 over integral of, I'm not going to rewrite all that, I'm just going to put T of T there. From 9 a.m. to 9 p.m. So I guess the trick is, like, what are my limits from what to what? If I go from 9 a.m. to 9 p.m., what T values does that correspond to? That's the trick to this problem. 0 is when we start, and 9 p.m. is how many hours later? 12 hours later. So 0 to 12, and then 12 minus 0, and now it's a calculator problem. And this counts as showing your work. Because T of T is defined up there, you don't have to rewrite 50 plus 14 sine pi over T over 12. Like, you can just put T of T when it comes to showing your work. So 1/12. Math 9, 0 to 12. Obviously, I've got to type in that formula or that equation here. 50 plus 14 sine. I like my fraction bars. Make sure I've got everything in the right spot. Okay, that should be it. 1/12, 0 to 12. 50 plus 14 sine. And so my average temperature then is 58.913. Degrees Fahrenheit. All right, 14. Glad you asked about 14, because it leads into what we're going to do today. Find the interval on which that curve is concave up. Okay, that curve looks really weird, but let's ignore the details of the curve. What does it mean for a graph to be concave up? The second derivative is positive. So y double prime greater than 0. Alright, there's I arguably have my justify point right there. We justified it, now we got to go figure out what that looks like. So I need to take 2 derivatives of this thing. As always, there's no shortcut to a second derivative. You have to just take a derivative and then do it again. So that means take a derivative of this whole thing. Again, think big picture before you start diving into the details. This is asking you to take a derivative of an antiderivative. So what's the derivative of an antiderivative? Or what do those two operations do? Yeah, they cancel each other out. You're back to the original. So now we just need to think about plug in the top minus plug in the bottom. So y prime is x cubed plus x squared plus 1. Well, let's go ahead and do it all the way out here. So times the chain rule, so we don't forget. What's the derivative of x? 1. And if I plug in 0, I get 0 plus 1 times 0, so all that goes away. But it's probably good to think about all of that, even though that gets wiped out. Plug in the top minus plug in the bottom. Don't forget the chain rule. Okay, so that worked out well because the derivative of an antiderivative gets us back to the original. I still want the second derivative, but now this is more straightforward. Now I'm just taking the derivative of a polynomial. So let's get some help on this one then. He's not here. Wait a minute. There is no Luke. Holly, how about the derivative of x cubed? 3x squared. Jimmy, the derivative of x squared? 2x. And Addie, the derivative of 1? That would be 0. Okay, so now I've done the hard work. Now I need to figure out where that is greater than 0. So let's set it equal to 0 and do the number line thing. X equals 0, x equals negative 2/3, 2/3, 0. I need to check something. I like checking 0, but I can't use 0. Let's check 1. So the second derivative at 1 is 3 plus 2 is 5, so that's positive. And then I can do the alternating thing. I mean, you can check more if you want, but plus, minus, plus. So we were looking for where y double prime is positive. So y is concave up on negative infinity to negative 2/3, and then 0 to infinity. Because y double prime is positive. So we combined a couple of ideas in that problem. The new idea was the derivative of an antiderivative gets us back to the original. That's the stuff from this unit. Stuff from prior units was concavity and multiple derivatives and number lines and testing and all the rest of that stuff. Okay, perfect lead in. Let's grab the notes packet and let's do that last example. There's almost always an AP question like this. Almost always. Which means I guarantee you there will be a question like this on your test next Thursday. Like, promise you, there will be one very similar to this. I mean, I can make the picture different. I can put different lines and circles and stuff on it. I can make my starting point not necessarily 0, but then the rest of these questions are going to look really familiar. It's going to be very similar to this page. Okay, the graph of a function f Okay, so let's be careful about what we're looking at. Function f is what we're looking at. There's the graph of function f. Consists of a quarter circle and 3 line segments. All right? As shown on the left. Let g be the function given by, g is the antiderivative of f from 0 to x. But we might want to be thinking, remember that symbol means 2 different things. It means antiderivative, but given what we have for this problem, what else do we know that means? What's that? Area under a curve. So this is most likely an area under the curve problem when they give me a graph that has like recognizable geometric shapes in it. So triangle, oh, that's like a trapezoid, but we can piece together that area, and a quarter circle. Okay, find g of 0, g of -1, g of 2, and g of 5. Okay, g of 0. So g of 0, that just means wherever x is, you put an x in. So this input value goes at the top. What's this answer going to be before I write anything else? 0. Right? Area under the curve from 0 to 0 is nothing. So as soon as I write that, hopefully my brain is turned on and I realize, wait a minute, I don't have to do any more on that one. That's 0. G of -1. So the -1 goes at the top. Oh, something's kind of weird about this one. It's like backwards. So how do I fix the backwards? Make that negative out front. So some people will show this step, others will just make their answer negative. I'm going back and forth between t and x. That's probably not the best format, but it's really okay either way. So the area from -1 to 0, that would be that first triangle here. Let's see, 1/2 base times height. That area is 1. So be careful though, that means my g of -1 is -1, because we went backwards. Alright, g of 2. So 2 is my input. So the area from 0 to 2. I like this one better because we're moving forward. I don't have to worry about negatives and switching things around. So 0 to 2 is the circle, or the quarter circle, I guess. Let's see, pi r squared is 4 pi, but 1/4 of that would be pi. G of 5, same thing. 5 is my input, that's my x value, so that's what goes in at the top up here. So I need the area under the graph from 0 to 5. What do I need to be careful about here? There's some negative area, so pi and then minus whatever these two things are. I'm going to divide these up. That one's -1, that's easy. The other one's a trapezoid, but I don't know. You really want to do a area of a trapezoid formula? Or do you just want to divide it up and like count the squares? Or yeah, just count the squares. 1, 1, 1. So -3. There's 3 squares there. So from 0 to 5, pi minus 4.
Why is the 1 isn't even in the problem, but why is it not negative? Or is it?
On the first one.
Very.
Because we put that as -1, but then on the graph we didn't put that.
This one?
Well, yeah, I'm just asking.
Okay. So the area is 1, but that area is 1 if you're moving in the positive direction. If you're moving left to right, you would say that area is 1.
Okay.
But this problem had us go from 0 to 1. It had us to go backwards. That's what made it negative. Does that make sense?
Yeah.
Okay. So there's two things that can make things negative. You can move backwards, or you can be under the axis. Which means if both things happen, then you end up with a positive, right? If you go backwards, but you're backwards, but you're under, then you end up with a positive area. Takwa?
For the area that's -2, are we not counting the little piece that's cut off?
This area, that area is -3 altogether. And I just counted the squares. 1 square, 2 squares, and then this triangle makes 1. So 1, 2, 3. I mean, you can do the area of a trapezoid, which we should know, because that's base times average height. We've done those. But you could do it that way, but you'd end up with 3. Okay, so there's part A. Part B. Find all values of x on the open interval at which g has a relative maximum. Justify your answer. Okay, well, let's justify first. Not even worried about this problem. G has a relative max when, again, not on this problem, but just in general, if G has a relative max, what's going on with G? What's going positive to negative? We've got to be clear here. G prime. So when G prime changes positive to negative. That's my justify statement. So that's what I'm looking for. Now let's go to this problem in particular. I don't really have G prime. I've got G, but I would like G prime. G is this. I'm just copying this down. That's what G is. So how would I get G prime? Take a derivative. Derivative of the left is just G prime. That's why we did this. What's the derivative of the right-hand side? F of x. Because it's the derivative of an antiderivative. Derivative of an antiderivative. It's like, yes, that's the whole point of this lesson, is those two things cancel each other out. Plug in the x. Chain rule is just 1, so I don't have to worry about it. So that is a big deal for this problem. So where G prime changes positive to negative, that means where F changes positive to negative. Because G prime is F. Okay, well now this problem just got real easy. So where does F change from positive to negative? At 2. Be careful, not the slope of F, just the value of F at x equals 2 changes from positive to negative.
Why is it F of x and not F of t?
So this is F of t, but when we do this derivative, antiderivative, that cancels each other out. Plug in the top. Minus plug in the bottom, chain rule. So we land at just F of x. What if that bottom number wasn't 0? What if that bottom number was -2? How would that change the derivative? Trick question. It wouldn't, because you plug in -2, but then you multiply by the derivative of a constant, it goes away. So minus f of a constant times 0, all that stuff would go away. All right, part C, find the absolute minimum value of g. When you see the word absolute, that's supposed to trigger something in your brain to check the endpoints. So find the absolute minimum on -1 to 5 and the value of which it occurs. Justify your answer. Okay, well, a table will justify my answer, so I need to check -1 and 5. Those are my endpoints. And then I should check critical points. So endpoints and critical points. Critical points would be where G prime changes signs, but we already sort of already answered that. G prime changes signs only at x equals 2. If you're really paying attention, you could not check x equals 2. Do you know why we don't really need to check x equals 2? Because it's a maximum. X equals 2 we already said was a relative max, and we're looking for a min. So if you identify that as a max, you don't need to check that one, because a relative max can't be an absolute minimum. That wouldn't work. The good news is, and this happens a lot on the AP test, and hint hint on my test as well, on this further down stuff, we've already found some of this information. G of -1 was -1. G of 2 is pi, even though we already know that's not going to be the answer. And G of 5 is pi minus 4. So we're looking for the absolute minimum. As expected, it is definitely not at 2. Oh, which one of these is smaller, -1 or pi minus 4? It's kind of close, but -1. Right? 3.14 minus 4 is 0.9 something. So -1 would be the... Oh, I don't like that they're both -1. That leads to a possible confusion here. So -1, the y value is the absolute minimum. And it occurs at x equals -1. So that's not the best example, because both of the answers are -1. So if you got them backwards, you'd still get it right. Kind of nice. The min or max is the y value. Where it happens is the x value. D, find the x-coordinate of each point of inflection on the graph of G. Point of inflection of G. Abby, how do I find the point of inflection of G? Not on this graph, not for this particular problem, but just in general. What does point of inflection mean? Maybe, when what changes from increasing to decreasing? I wouldn't have worded it that way. Like, you can get there going that way. Which derivative do we usually associate with point of inflection? Yes. So then what about double prime? Changes sign, but that's different than increasing to decreasing. Okay? So changes signs. If you had said G prime changes from increasing to decreasing, that would be right, but that's a little more confusing way to think of it. Let's just stick with G double prime changes signs. So I need something about G double prime. This is good news. We've already done the hard part. If G prime equals f of x, rewrite that. So G prime equals f of x. What do we think G double prime equals? F prime of x. We could take the derivative of both sides. So for this particular problem, like G double prime changes signs, that's always true for point of inflection. But for this problem, let's sort of combine these two ideas. That means F double prime, F prime changes signs. So if you write, so you don't need to write both of those as long as you had this. So you need one of these statements, one of these two statements. Right? You don't need to say F prime changes signs if you've already told me that F prime is equal to G double prime. Then you can put it together, that's fine. You also don't need to say this if you said this. So you got to have one of those. My preference is that you show this because that's sort of the point of the problem. Yeah, that's what you were getting at, I think. So what am I looking at on the graph of F if I want to know where F prime changes signs? Slope of F. And again, you wouldn't have to say this, but F prime is the slope of F. Okay, so like 3 steps later, now I'm looking at the graph of F. I'm looking for where its slope changes signs. So Caden, give me one spot where the slope of F changes signs.
0.
Okay, I like that answer. Lexi, I think there's one other spot where the slope of F changes signs. At 3. So 0 and 3. F changes directions, which means F prime changes signs. Thinking backwards, if F prime changes signs, that means G double prime changes signs, and that means I've got a point of inflection. And if you can step back for a half a second here, you can realize why they almost always put this on the AP test, because it tests like 100 different things all at once. You've got to be able to take the derivative of an integral and realize that gets you back to the original. But then we had to think about increasing and decreasing and maximums and minimums. And then we had to do a second derivative to get the first derivative for points of inflection. We also did area under the curve. So again, that problem is frequently on the AP test. And I would even go so far as to say it's frequently a free response question. It's always in there somewhere, but it's frequently a free response question because they can do so much stuff with it.
Is it on your test?
It is on my test, yes. It is on my test next Thursday as a free response question, and it looks a whole lot like this. Right? I mean, it's a different picture. I think I picked a different starting point, so that affects finding area, but it doesn't really affect the rest of the problem, because once you take a derivative, that bottom constant doesn't matter. Again, I don't remember exactly what it looks like, but it'd be easy to switch out relative max, relative min, absolute max, absolute min. There's not much you can do with point of inflection. But yes, you're going to see one really similar to this one in terms of process. Different picture, but process the same. Okay, and because of that, that's another reason I wanted to spread these notes out and put this one on its own day. So we're up to worksheet 4, review worksheet. I don't know what we're, I think, worksheet 4. So I'll say today's assignment is worksheet 4, 1 through 21. Monday's assignment is worksheet 4, the rest of them. And then Tuesday there won't be an assignment. I'll just work problems in class. So you can sort of start to plan ahead and think, when is best for you to do that last worksheet. Tuesday, no new assignment. So that's kind of the plan moving forward, and obviously Thursday is the test. So I meant to take note of the time. I think we started this problem at like 12 minutes, and now we're at 30 minutes, so that means it took us 18 minutes. It's supposed to take 15, but we took a little longer because it was our first time through, and I explained lots and used lots of pretty colors and pictures and whatever.